Hi, welcome to Pre-AP Physics, Unit 1.1. This is called TUVE, Terms, Units, Variables, and Equations. And let's get started. The objective is to identify units and variables given the equations and perform some dimensional analysis of displacement, which is distance or position, velocity, which is speed, acceleration, and time to achieve the consistency of units within the problem. Let's look at the definitions. Distance is the amount of space between two places or things. Displacement is the change in position of an object. Length is the measurement of an object or space in one dimension. We are going to refer to those three as being different and distinct. However, sometimes those words will get interchanged. Speed is the magnitude of the velocity, okay, the travel of a distance over a period of time. Velocity is the speed of an object in a given direction. Again, those are going to be interchangeable. Acceleration is the rate of change of velocity. Time is an indefinite continued progress of existence and events. Let's talk units. Distance, displacement, and length are all measured in meters. Speed and velocity are measured in meters per second. Time is measured in seconds. Acceleration is measured in meters per second or meters per second squared. Looking at the variables. There can be multiple variables for given terms. Velocity is represented by v and v naught. The change in velocity is represented by delta v. The triangle shape is the Greek letter delta. Acceleration is represented by a. Distance is represented by x and x naught for horizontal motion, y and y naught for vertical motion. Displacement is represented by delta x and delta y. Time is represented by the letter t. 0 stands for the initial, or naught stands for the initial position or velocity or whatever you're looking at. Now let's look at equations. The basic kinematic equations are kinematic simple, x is equal to x naught plus vt. Kinematic 1 is v is equal to v naught plus at. Kinematic 2 is x or y is equal to x or y naught plus v naught t plus 1/2 at squared. And kinematic 3 is v squared is equal to v naught squared plus 2a delta x or x minus x naught. Dimensional analysis. Dimensional analysis is the process of converting one set of units into another. Set up a series of multiplied fractions, multiply across the top and divide the units through the bottom, canceling those units. This class will operate primarily in the metric system, but we will have to convert between standard and metric. Standard unit equivalence. 1 kilometer is 1,000 meters. 1 meter is 100 centimeters. 1 mile is 5,280 feet. 1 inch is 2.54 centimeters. 1 foot is 12 inches. 1 minute is 60 seconds. 1 hour is 60 minutes. Let's look at some sample problems. A rectangular field is 100 meters by 50 meters. A man walks the perimeter of his field in 112.2 seconds. At what velocity did he walk? Your job is to identify the units, terms, and variables represented in this question. So m is a unit. It stands for the horizontal displacement. X and x naught are implied. S is time in seconds. And velocity is v in meters per second. Same question, what equation should we use to solve this would be kinematic simple. X is equal to x naught plus vt, noting that x and x naught must be further defined. Part 2. If an object travels 8.96 meters per second, what is its velocity in miles per hour? You set up a dimensional analysis to convert meters per second to miles per hour. Notice that we start with what we're given, 8.96 meters per second, top and bottom. The meters then transfer down diagonally to the right, and we convert those to centimeters based on the chart that you were given earlier. The centimeters then get converted into inches, inches into feet, feet into miles, which is what I want to end up with. Then we go back and grab the seconds. Seconds, it gets transferred up diagonal to the right, changes into minutes, and the minutes change to hours. Multiply everything across the top and divide by everything on the bottom, and we get 8.96 meters per second is the equivalent of 20.04 miles per hour. All right, let's finish your formula sheet. Kinematic simple is x is equal to x naught plus vt. X stands for the final position, the displacement from the origin in meters. X naught is the initial position, which is not always at the origin. Again, its units are meters. V is the velocity in meters per second, and t is time in seconds. Kinematic 1 is V is equal to V naught plus AT. V is the final velocity in meters per second. V naught is the initial velocity in meters per second. A is the acceleration in meters per second, and t is time in seconds. Kinematic 2, x is equal to x naught plus v naught t plus 1/2 at squared. X is the final position, the displacement from the origin in meters. X naught is the initial position in meters. V naught is the initial velocity in meters per second. T is time in seconds, and A is the acceleration in meters per second. Finally, kinematic 3, V squared is equal to V naught squared plus 2A x minus x naught. V is the final velocity in meters per second. V naught is the initial velocity in meters per second. A is the acceleration in meters per second, and x is the final position, the displacement from the origin in meters, and x naught is the initial position in meters. All right, we'll do more in class. Thanks for watching.